Welcome to this lesson on ions. Ions are a fundamental concept in chemistry that help us understand how atoms behave and interact with each other. Today, we'll explore what happens when atoms gain or lose electrons, transforming them into charged particles called ions. This knowledge is essential for understanding chemical bonding, reactions, and many processes that occur in nature and our daily lives. Before we dive into ions, let's review the basics of neutral atoms. Every atom consists of three main components. First, we have protons, which carry a positive charge and are located in the nucleus at the center of the atom. Second, we have electrons, which carry a negative charge and orbit around the nucleus in shells. Third, we have neutrons, though they're not shown here because they're neutral and don't affect charge. In a neutral atom, the number of protons equals the number of electrons. This balance means the positive and negative charges cancel each other out, resulting in a net charge of 0. This is our starting point for understanding ions. So, what exactly are ions? An ion is simply an atom that has gained or lost electrons, resulting in an electrical charge. Remember, in a neutral atom, protons equal electrons. But when this balance is disrupted, the atom becomes charged. There are two ways this can happen. When an atom loses one or more electrons, it has more protons than electrons, making it positively charged. On the other hand, when an atom gains one or more electrons, it has more electrons than protons, making it negatively charged. This process of gaining or losing electrons is what transforms a neutral atom into an ion. Let's focus on positive ions, called cations. The term cation is pronounced cation. Cations form when atoms lose electrons. Think about what this means. If an atom loses electrons, it now has fewer negative charges, but the number of positive protons remains the same. This imbalance means there are more protons than electrons, resulting in a net positive charge. The key relationship here is simple. Protons are greater than electrons, which equals a positive charge. Cations are extremely common in chemistry and play vital roles in everything from table salt to the electrical signals in your nervous system. Let's look at some common examples of cations. Sodium, represented as Na with a plus sign, forms when a sodium atom loses one electron. Magnesium, Mg with a 2+, loses 2 electrons. Aluminum, a L with a 3+, loses 3 electrons. Potassium, K+, loses 1 electron. Calcium, Ca2+, loses 2 electrons. And iron 3+, Fe3+, loses 3 electrons. Notice the pattern. The number before the plus sign tells us exactly how many electrons were lost. For example, calcium 2+ means calcium lost 2 electrons. These cations are found everywhere, from the minerals in your bones to the electrolytes in sports drinks. Now let's explore negative ions, called anions. The term anion is pronounced anion. Anions form when atoms gain electrons. This is the opposite of what happens with cations. When an atom gains electrons, it now has more negative charges while the number of positive protons stays the same. This imbalance means there are more electrons than protons, resulting in a net negative charge. The key relationship is, electrons are greater than protons, which equals a negative charge. Anions are just as important as cations and are essential for forming compounds and conducting electricity in solutions. Here are some common examples of anions. Fluoride, F with a minus sign, forms when a fluorine atom gains 1 electron. Chloride, Cl-, gains 1 electron. Oxide, O2-, gains 2 electrons. Sulfide, S2-, gains 2 electrons. Nitride, N3-, gains 3 electrons. And bromide, Br-, gains 1 electron. Again, notice the pattern. The number before the minus sign tells us how many electrons were gained. For instance, oxide 2- means oxygen gained 2 electrons. You encounter these anions daily. Chloride is in table salt, fluoride is in toothpaste, and oxide ions are in rust. Understanding how to write ion symbols is crucial for communicating in chemistry. The notation is straightforward. For positive charges, we write the element symbol followed by a plus sign as a superscript. For example, sodium ion is written as Na+. For negative charges, we write the element symbol followed by a minus sign as a superscript. For example, chloride ion is written as Cl-. The number before the sign is very important. It shows how many electrons were gained or lost. If there's no number, it means 1 electron. Calcium 2+ means 2 electrons were lost. Oxide 2- means 2 electrons were gained. This notation system allows chemists worldwide to understand exactly what ion is being discussed. You might be wondering, why do atoms form ions in the first place? The answer lies in stability. Atoms naturally want to achieve the most stable electron configuration possible, which means having a complete outer electron shell. This is called the octet rule. Most atoms want 8 electrons in their outer shell, similar to the noble gases like neon and argon, which are extremely stable and unreactive. Atoms will gain or lose electrons to achieve this stable configuration. For example, sodium has 1 electron in its outer shell. It's much easier to lose that 1 electron and achieve stability than to gain 7 more. On the other hand, chlorine has 7 electrons in its outer shell, so it's easier to gain 1 electron than to lose 7. This drive for stability explains why ions form and why certain elements tend to form specific types of ions.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.